highway for the fuel to go around, the waste to go eliminated, and also the hormones to regulate all this metabolism. So they can go 1 meter or more, let's say. Let's look at the pancreas. Pancreas is divided in two parts, endocrine and exocrine, and the part that we are interested in for this part is the Langerhans cells, isolate of Langerhans. So this area here is rich of blood vessels, which are these guys here in cross section, and they have three main types of cells: alpha, beta, and delta. Okay? Alpha cells will produce glucagon. The beta cells will produce insulin, and the delta cells produce somatostatin, which is not involved in what we are doing, but since we are here, we just put that in a place, just to know. Okay? So, alpha, glucagon, beta, insulin. Insulin is secreted when I get a brownie, because I have to keep the sugar in my blood at a certain concentration. If it's going too high, it's not going to be good. So the main point here, and I think you should keep this in mind every time that all the time that we're studying, is that the concentration of sugar in our bloodstream should be constant. Okay? Should not go too high, should not go too low. Either way we will get really sick or could die. So the hormones that control those levels are insulin and glucagon. If there is too much sugar because we ate, insulin is secreted. If there is too little sugar because we are far away from our last meal, glucagon is going to be secreted. And what is going to do to glucagon is going to wake up all the storage of sugar that we have in our body. Okay? So that is the big picture of it. So what we need to look, we will not look to each cell of the body. We know that pancreas is still giving these hormones. What other organs will be very important? I would say three main important organs. One would be the muscles. We can opt to muscles or brain. They are kind of similar, but not equivalent. I give you one big example. Muscles, we have little droplets of stored glucose in the form of glycogen in the muscles, while brain doesn't have that. But brain needs a lot of glucose. So how brain gets the glucose is the pancreas doing that for the brain. The pancreas, the liver. The liver is doing that for the brain. And also the liver has a huge storage of glycogen, which should be physiological until a certain point. Unfortunately, when it gets too bad, too much, that is connected to some not healthy situation. And it's very interesting that steatosis, that is one of the situations which there is too much glycogen in around the liver, is something that is happening now in countries like the United States, even in kids that are 10 years old, 10, 12 years old. That usually should happen only in who is really overweight or who is drinking a lot. So drinking alcohol, beverages a lot. Okay, so that is kind of a big picture. Now, a couple of words about the chemistry involved there. So we're making a huge jump. I went from really big picture, almost anatomy, organ organization and function, and now I'm going to look at what we have to look on the chemical side. We will see a lot of oxidoreduction reactions. So reactions that have oxidation and reduction. And they cannot be alone. They have to be always, if a molecule is oxidative, another one has to be reduced. So what that means that Oxidation, there is some atom that loses electrons. Reduction, an atom that gains electrons. What is our main atom? Is carbon, because our biology is the biology of carbon, right? So what would be the oxidation state of the carbon? That will depend on the molecule that are, the atoms that are attached to it. Carbon can have a value that is from +4 to -4. And that is all depending on what other molecule is attaching. To be more specific, if a carbon is attached to the molecule of oxygen, the oxygen, once it's removed, will take all the electrons. If it's attached to a molecule of hydrogen, is the carbon keeping the electrons. If carbon is attached to another carbon, they will share the electrons. So when we look at this, we can take a look at this table with the different groups that contain carbon, and we can identify the oxidation number of the carbon that that would be when we ideally remove those other atoms that are binding that carbon, and by following the rule that I just told you, allocate the charge that the carbon will have eventually. So the main part of metabolism for us will be understanding and learning which enzymes are involved and how they work. How they work means also how they are regulated. So for now, we can see that metabolic enzymes are relevant because they have a very high speed, they are very specific, and they can be coupled. This will be on the last slide, this what it means. But the other way is that which type of reaction they can mediate. Redox reaction, you remember we had the 6 main families of enzymes: oxidoreductase, transferase and hydrolase, isomerase and mutase, hydrolysis, lysis and ligases. And here is all the function that they can do, all the reaction that they could do during a metabolic pathway, during, let's say, catabolism of glucose. Where they are doing that. In a way, we can use the real estate marker slogan, location, location, location. So enzymes work in a specific place within the cell. If a glycolytic enzyme is within the Golgi, that is a mess, cannot be that. All the glycolytic enzyme and gluconeogenic enzyme has to be in the cytosol. While the citric acid cycles enzymes, they are in the mitochondria. There are also all the other electron transport enzymes are located. Mostly mitochondria and cytosol are the 2 main places where all the metabolism that we are going to study will take place. And when the molecule moves from one place to the other, we will look also to the transport of those molecules, because it's also another way in which we can regulate the metabolism. So if you make a barrier from the mitochondria to the cytosol, that things cannot happen, right? So how things move is also relevant. This is just a visual image. That is the same thing with the previous one as a table for those of you that nicely study. Okay, so let's take now the attendance. I can read a little bit.